Your background's awesome.
What?
I love the background being outside. It looks.
Uh, well, you can't see very clearly that I need to mow my lawn, but yes, it is good. I'm enjoying being outside. Unfortunately, I'm going to have to wipe my eyes with a clean tissue because the pollen gets to me, but it is a price I pay. Okay, lots of announcements. First of all, in the lecture notes, when you scroll down to our Math 25 lecture notes, then I've put a official health decisions if you want to take it optional midterm. What had happened before was someone said, oh, I want the check mark for doing well on a midterm. So that's great. And so what they did was they went over to the playgrounds page where they can get a midterm, and then they clicked on the midterm. They were in Math 20, so they did shape-shifting, and they were good. I don't think they cheated and looked at the answers, but when they sent me their work by taking a picture of their paper, I didn't have an answer key to it. So it took a long time to grade because I had to actually solve every problem and not just use an answer key. So that didn't work. So what I have done now is on your lecture notes, put a sample midterm here. So this is just a random one. There's nothing special about it, except that I have the answers so that if you want to get the check mark for doing a midterm, then you can. And there we go. So that's the first thing, is that's what this grayed out bar is. And it also kind of helps separate the health topic from the personal finance topic. So lecture notes, look for that if you want to do that. You might have noticed just now that I've reorganized the playgrounds page, and there's two ways this affects you. The main reason I reorganized it was before sorted just by what I liked the most, but you don't care about that. So the reflections are good things to do at the beginning. Yeah, that's mostly for Math 20, but it wouldn't be bad for you to look at those. The ones you care about a whole lot in Math 25 is the big issues. The explorations are fun things to do. And then there's things that help you practice your math skills. So I'm calling those gymnasia, and you can read about why. Again, mostly Math 20, but if your multiplication times tables are rusty, you can see if you can do this in 3 minutes. You can get a check mark for doing that. You actually, whether or not you know it, know 10 different ways to think about 47/100ths. So this page, if you look at it, is a matching game. So you're just trying to match them up. You can see the answers. So you can practice and see how quickly you can match up 47/100ths in different contexts. In Math 25, this is your first big change. You didn't have little midterms. And I thought, that's just me being lazy. So I will take your overall test, which if you remember has 40 problems, and break it up into the parts. So the health decisions midterm is nothing else other than the 3 out of 10 review problems that was there before. And here's just the first 14 problems. Other than that, all I've done is cut the end off your end of term test. And then for personal finance decisions, you have the middle 12 problems. And then for business decisions, you have the last 14 problems. So it's just, what?
I forgot to do that test this weekend.
That's okay, you can do one. But this way, if you want to take a practice test, you don't have to kind of be awake enough to stop early and say, oh, we haven't gotten this far yet. You can just practice the section you want to practice more easily. And that again lets me put one of them that I have an answer key for. So if you want to take one to get the check mark that you've gotten 70% or more, then please take the one I have an answer key for. Otherwise, it takes too long for me to grade.
Okay.
Then, but mostly what you care about is your overall test. Okay, then the big announcement is the achievements. I spent a lot of time on Friday helping my 12-year-old with his 4J schoolwork and got great sympathy for just that things were too complicated. So I have simplified your achievements greatly. So it is still true that to get a plus or a minus, you do the same things. But now for getting an A or a B or other grades, then you just need so many stars in the How Real Math Works subsection, and the Being a Mather subsection, and the Homework subsection, and then a certain score on your final. I'll talk about these bits in a bit. So before you needed to have like things in each brown subcategory, but now you don't. Just stars are stars. Get stars with the green background, get stars with the blue background, and you don't have to worry about which subsection they're in. That seemed to be too much potential confusion and annoyance. The reason it used to be that you needed subsections was because some of the classes that you are going into have required that Math 20 make sure you can either write homework neatly or turn in some well-written notes. So well-written notes is only for an A. Turn in homework neatly is do it twice for an A or once for a B. So rather than embed those down below and make sure that you did them that way, I've just put them directly in the A and the B. So it's not more work that I moved them here. And that way I can release the restriction of having to do subsections. And it's just, yeah, all green stars are the same. All brown stars are the same. So that makes it much easier for you to get enough check marks. I've taken a few achievements and changed them to make them easier because we're doing distance learning. So one of them is to, there's the little quizzes I just mentioned. I took the hidden curriculum one and moved it down here because it's just too hard to necessarily find someone who's struggling with that when you're not around other people. The work with a tutor, it used to be that you would have to visit the MRC, the Center for Accessible Resources, and TRIO, and visit all three of them for one check mark. And that was easy if you were on campus. That was like a 20-minute walk. But now it's harder to do. You have to make appointments online and blah, 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 blah. Not to mention that TRIO now has a waiting list, which it hasn't before last term. So I've separated it out. There's a new star just for working with a tutor, whether it's someone you live with that's good with math or someone from the MRC or whatever. And if you work with CAR or TRIO, not necessarily both, then that's another star. Then I've changed the 5 homeworks on time. It used to be 6. This one used to say take 5 practice tests, but I realized for time management it's more honest to just say, tell me when you've scheduled them. And whether actually taking them will be its own reward, because then you'll know how you're doing. And I put the neatly written homework steps here for keeping track of them better. So overall, things are slightly easier and much simpler. So check which achievement stars you've earned in case you have some that aren't checked off but should be, and all of that. Okay, questions about the announcements, either for the optional practice midterm, the way that this page was reorganized, or how your achievements work?
So when is this all due? Like when, or like what's the time frame on all this?
What's the time frame on all this? The only thing that has any time frame as far as the grading itself goes is that you can't turn in 4 late homeworks. Otherwise, you'll either get a minus or you're forced to earn lots more stars to get the plus.
Okay.
So if you have 3 late homeworks, you're fine. Nothing else here has a time limit on it. Some things just because of their nature are good to do at certain times. So trying to do a midterm to make sure you don't forget the health decisions is probably better to do sooner rather than save it for week 9. By the time we get to the end of the term, you'll be doing practice finals, not just only the health decisions problems. So certain things are just sort of good to do, but other than that, don't have more than 3 late homeworks is the only rule. And I don't think anyone actually is in trouble with that. So far, so good.
Okay.
Any other sort of how class is going questions? And I will close these. How about math topics? Any questions about the math we've done? I suppose I should be good and look at our calendar too, huh? Oops. This one. So for Math 25, we had bell curves and typicality due. We don't have a due date for mortgages yet. So somebody asked me a question on mortgages. Otherwise, that will be due next class.
Did you say this Thursday?
Yeah.
Okay.
Anyone still confused about mortgages? Have we done enough of that?
I think I'm good on it.
Okay. Well, then I'll keep going forward. So where we left off yesterday was two things. We learned this 1 plus trick, that if I want something to get bigger by 12%, then instead of multiplying by 0.12 to get $12 and adding it back onto the 100 as a second step, all I have to do is multiply by 1.12, because times 1 means don't change it. So the times 1 keeps the 100 around, the 0.12 makes it 12% bigger, and we get our answer in one step. And I'm sort of lying, because there's 2 steps of slamming a 1 in front of the decimal. But putting a 1 in front of a decimal is so easy, it's almost not really a step. So we did that a couple times. The times 1 keeps the 1,000 around. The 0.08 makes it 8% bigger. Then we said that was great, but it wasn't universally useful. If the time frame is more than 1 year, I can't use the 1 plus trick. I have to find the interest each year, make copies of it based on how many years go by, and then take another step to put them together with addition. So the 1 plus trick did not work with a longer time frame. We also said the time frame might not be $12 5 times, but it might be you paid off your loan before a year was done. And then the time frame still measures years, so 200 days is 200 over 365. And with calculators, you can just treat the fraction bar like a division symbol. Does that all ring a bell from yesterday? Does anyone want me to do more of those? Or not yesterday, but last week.
We could do a refresh.
You're gonna do a refresh? Okay. So I'm gonna close the old Jamboard, and here is our new Jamboard for today. And let's go back and talk about simple interest a little bit. So I'm gonna make that slightly, oh no. That one we did. Let's get a random one so we get something new. Here's a good twist on it to make it more exciting. Does everyone know what a post-dated check is?
I don't.
So that's not quite wide enough. Okay, let me write and then I will explain. Okay, and I'm also going to open a new. So tangentially, if you go in the big issues, then I can find is there some no, I thought it was there. Somewhere on this website, I have an article about payday loans. That's interesting to read. But what happened is Joyce needs a payday loan. She gets paid maybe once a month or every 2 weeks, and she doesn't have much savings, and something bad happened. Her car broke down, her water heater broke, who knows what. So she needs $782 now. So she goes to a payday loan store and says, I need money, but I have a good job. I know I will get paid in a few days, and then I can pay you back. And so she doesn't have to make the trip back to the store. She will write a check, and the check will include not only the amount she borrows, but a little bit more. See how her check amount is slightly bigger? So she's including the interest in her check. And she doesn't date it for the day she's at the store. She dates it for 29 days later. So this isn't something that the payday loan store can deposit and get money from Joyce's bank until 29 days go by. And then the check becomes a current check, and the payday loan store can put it in their bank and get the money out of Joyce's bank, and the deal is done. So by writing the date on the check in the future, she doesn't have to come back to the store later on to pay off the loan. It just saves her a trip. Did I explain that well enough?
Yes.
Okay. So this is not quite a realistic problem. Again, the random problems are random. Very few payday loans in real life last 29 days because by then you would actually get a paycheck. But this kind of thing happens all the time for shorter periods of time. People just need a little money between now and the next paycheck. Okay, so we are trying to find the simple interest rate. And what we did last time didn't have a formula, it just had steps. So let me actually bridge the gap to the formula. Bring that one back open that I had closed. So to find the simple interest, first we multiplied the interest rate by the amount of the loan. Again, this was called the principal to be fancy. So we did the rate times the principal. And then when we were done, we multiplied that by how many years or what fraction of a year the loan lasted. So it was just three things multiplied together: the rate, the principal, and what fraction of a year. It doesn't matter what order we do that, because when you multiply things, you can do it in any order. So to help emphasize that, people have made a formula that just says what we did. And there's nothing special about this formula. It's not like anyone had to do a bunch of looking at patterns like we started the class with. This is just sort of the definition of how simple interest works. You're going to take the principal, multiply it by the rate, and then either by how many years or what fraction of a year things are happening. Actually, I'm going to shrink it a little so I have some space. But writing it out like this is nice because sometimes we don't just plug in these three like we did when we were warming up last week. Sometimes we're looking for one of those three. So the formula helps us see that. So when I take this formula, I'm going to list out the four things in it. So we have the interest, the principal, the rate, and the years. Because if anything funny is going to happen, it's going to be before we plug it in. It's exactly the same mindset as when we were doing all of the other formulas and health decisions. And if something funny was going to happen, it was because they gave us a height of 5 foot 8 inches, and we had to change that from a mix of feet and inches into only inches or something like that. So all of the funniness is going to happen here in blue. Plugging things in is actually going to be more straightforward. So in this case, it's asking what is the rate. So the rate is what we're solving for. The years is 29 days. So that's going to be 29 over 365 of a year. Would I mark it wrong on your paper if you did 1/12, because 29 days is about a month? No, I wouldn't mark it wrong, but I'm going to sort of do it the right way and say this is about days because they gave us days. The principal was 782. How do I find the interest?
Wouldn't it be you would times the 70 or 782 by the 29 days divided by 365?
No, that's if I'm working forward. That's if I'm plugging in
We
these
subtract,
finding the interest. I
we
subtract.
subtract the 7.
Yeah, she doesn't love the payday loan store. She is not giving them any money. So with the amount she wrote the check for, if it's not paying back the loan, the rest of it is going to be interest. So that's going to be $8 to get to $7.90 and then 6 more, so $14.91. If I did that right. Does that make sense now?
Yeah.
So I have my things organized. Now I can actually plug it in. So simple interest is the $14.91. The principal is going to be the 782. The rate, I don't know. I'll just call it R. And the years is 29 divided by 365. Is everyone okay with my little thing I did but not right about of changing a fraction into top divided by bottom? Okay. Now, don't write what I'm going to write. You've seen lots of formulas that look something like y times 4 equals 12. Something is stuck onto y with times 4, so the opposite is divided by 4. If we do that to one side, to be fair, we have to do it to the other, and we get y equals 3. Right? That all is old hat. We're good at that. So we want the same thing. We want our letter to be multiplied by one thing so we can do the opposite and get the letter by itself. But this letter is sort of buried in the middle of things. So watch what I do to make it look like what we're used to. You don't have to do this all these steps once you get good at it. Like a lot of what we do in this class, then some of this is just sort of to make it clear as I'm lecturing when we're new at this. I'm going to say these two things, it doesn't matter what order I multiply them. Because when I'm just multiplying two things, it doesn't matter what order. And on this side of the equation, I'm going to start on this side because all I have is multiplying and dividing. So these I'm going to swap. Okay. So I'll have the R come first and the 782 come second. And now I'm going to say that all of this stuff is really just one number. I might not know in my head what it is just looking at it, but if I did 782 times 29 divided by 365, I would get a number. I'm going to grab the screenshot now because I'm going to do this in 2 different ways, which will make different people happy, and that's okay. Okay, if I want to be a little more careful, a little more do extra steps because I like that, then I'm going to, as my first step, do that math. So what is 782 times 29 divided by 365? So 62.13. And I'm rounding, so I should be good and right rounding. Now I am where I want. I have my letter times one thing equals something else. So I'm going to divide by that one thing. To be fair, if I did it on one side, I have to do it on the other. And I don't know what that is, but let's figure it out. So 1491 divided by my answer. So I'm getting about 0.24. And I'm not quite done. It wanted a rate, and it's not really a rate unless you write it in percent format. So that's going to be 24%. So look at that for just a moment. Now I'm going to finish it a different way. For some people, this step is a waste of time. They're going to say, this is one thing, whether or not I know that it's 62.13, it really is one thing. So I can go directly to, let's divide both sides by 782 times 29 divided by 365. And you'll need your parentheses key in your calculator, otherwise this is going to cause problems. But we have a parentheses key, so we're good. So I'm going to divide both sides by that. And you can check it. In your calculator, put $14.91 divided by parentheses 782 times 29 divided by 365, close parentheses, and you get the 0.24 with less writing. And I rounded here, so I should write it nice. So if it's okay for you to write less steps, you can. If this seems like you're cheating because you're dividing by 3 things, then go ahead and write the 3 things as one thing first so that it looks more like what you're used to. Okay, questions on any of that? Well, that's the hardest simple interest can be. What made it hard? They gave us the years as a fraction. They hid the interest from us. And rather than be the easier case where they give us these 3 things and the formula just spits out the interest automatically when we multiply, here they gave us the interest and we were looking for something on the other side. And beyond that, it was sort of the one in the middle, which makes it look funny. But this is all good, valuable stuff because we're about to go into compound interest. First, a heads up, most people write the simple interest formula just as I equals P times R times T. Principal and rate and the years becomes time. So if you're used to that, you can. But just be alert. It doesn't say simple interest anymore. So don't try using it for compound interest. It's not going to work. It's the wrong formula. It doesn't say that the time is in years. So be aware of that. When somebody gives you 29 days, you can't plug a 29 in. It has to be 29 over 365. So there's nothing wrong with writing the formula in a shorter way. It just doesn't remind you as much about how to use it correctly. So be careful, mimic example problems until you get used to it, and then you'll be fine. Okay, let's do another one just so that you are happy, that uses the formula and is easier. So this is the kind of forward direction one. Whoops, that one is bad. There we go. Okay. So same thing. If anything funny is going to happen, it will be in the preparation stage. So the loan is 3,500. The years is 9 months. So what should I write?
9 over 365.
Oh, that would be 9 days. Close though.
9 over 12.
9 over
Sorry.
12. The interest rate is 4.5%, and we're going to put it in a calculator, so we might as well flop it. And the interest is what we're solving for. So now I plug things in. And we get whatever all that is. $118.13. Much simpler when the interest is what they're asking us for. Questions about that problem? Okay. So that simple interest, it's good for payday loans, it's good for government bonds, it's not used much elsewhere. So what's happening with simple interest is each year, a little bit of interest is due. And at the end of the second year, another copy of that is due. And at the end of the third year, a third copy of that is due. The amount of interest never changes. It's just at the end of each year, you have another copy of it to pay. A similar thing is appreciation and depreciation. In this case, we said that money went up 4.5% with a loan and interest, but it could have been a $3,500 painting that is an old famous painting and the value went up 4.5%. Or it could be a piece of jewelry, or I don't know, whatever it is that people have that goes up 4.5%. So this is any kind of increase or decrease. It doesn't have to actually be a loan with interest. So we use slightly different words. and say appreciation for going up and depreciation for going down. We'll worry about that later. Okay, back to what we were doing. Here we have a table with rent going up. So the first year we have an apartment, we pay $500 a month in rent. And at the end of the year, the landlord says, costs are going up. I need to increase your rent by 5%. So we did something about 5% of 500. 5% becomes 0.05, of becomes times, and we got 25. So that's where the 25 came from. At the start of the second year, what are we paying for rent? Don't think too hard about it.
The 525.
The 525, right? And again, the landlord says, oh, costs have gone up. I need to increase your rent by 5%. It's not going to be 25 anymore. So now we're going to say, what is 5% of 525? And if someone's faster on the calculator than me, so what is it going to be this time? Okay, 2625. Usually I'm not the fastest one. So this is 26, 25. So add them up and we'll get 551, 25. Let me write it so it fits. Okay, how come these two numbers aren't the same? They're both 5%.
We used a different day.
Yeah, 5% of my income and 5% of Bill Gates's income are hugely different numbers. So 5% of a bigger amount is bigger. That's not surprising. Okay, so this keeps going. The next year, I'm going to start with a 551.25, and the landlord again says costs are going up. I need to increase your rent. %5 is 0.05, of becomes multiply. What's my new increase amount? $27.56.
20.
Did you get that also?
Yes.
So add it on, and we get 578.81. So we could keep going, but I don't want to waste your time in class filling out this table. You've seen how things are going. So here's all of our numbers if we were to actually do this. So question 41 says, what is the rent at the end of the 6th year? It was $670.05. If we kept doing that game year after year, that's what we'd get. 42, why does the amount of increase keep changing? We talked about that. The same percent of a bigger number will be bigger. What's the overall percent change? That's kind of interesting. So again, if we actually did this, we would get to 670.05. So here. So percent change is change divided by original. Remember that. If I have the 670, and I take away the 500 we started with, how much did it go up during those 6 years? $170.05. So this is going to be 170. And the original in this case is the 500. That's our first rent. So if I do 170.05 divided by 500, I get 0.3401, which is about 34%. There was a 5% change 6 times. So what's 5 sixes? 30, right? So 5% times 6 is 30%. And also 4% more. So 30% of this 34% just comes from, let's do 5% 6 times. The other 4, why it's 34 and not 30, is because we were getting bigger each time. It's not 6 copies of 25, it's 6 copies of something that's a little bigger than 25. And overall, that added up to 4% more. We could do the same thing with the 1 plus trick. Remember, the 1 plus trick only works for when the time frame is a year, but it is, so this is good. We could say 500 times 1.05 is 525. 525 times 1.05 would be the 551.25. The 551.25 times 1.05 would be the 578.81. And so on for the rest of them. And that's a lot faster. We were doing 2 steps each year, finding the increase first and then adding it on to get the ending amount. So we can skip the step. We don't really care that it was $26.25. We just care that at the end, the rent is now $551.25. We can make it even better. We can say, if my question is really what happens at the end of the 6th year, all I really care about is this box here. Then not only do I not care that this number was 25 and this number was $26 and change and so on, I don't care what any of these numbers are either. So this number here will be something, but I can just write it as 500 times the 1.05 times another 1.05. So that's times 1.05 squared. That's why I put that here, because that number always comes here, right? And then I'm multiplying it by another 1.05. So there was 2 already. Here's a third. So now it's going to be 500 times 1.05 cubed, which is why we wrote that here. Now we multiply it by another one. So we had 3. If you multiply it by the same thing again, now there's 4 of them.
It's kind of like the pattern thing.
Yes, this is why we did the annoying pattern topic at the beginning. And so it keeps going. So what is all of that? Do on your calculator 500 times 1.05 exponent 6. And you get the 670.05 that we had given away the answer before. Everyone see how this pattern works? It's the same math we were doing the long way on the first slide. It's just we're skipping lots of steps because we don't really care about all these intermediate values. Okay, so here is that. We could actually make this a formula, like in the patterns thing. We don't have to stop at 6. There's nothing magic about the number 6. This could be year 10 or year 100. Whatever it is, that exponent is going to be the same as the year. So our formula is y equals 500 times 1.05 to however many years it is. Everyone happy with our formula? We changed a pattern into a formula. So this formula is called compound interest. And if you've heard about that but not really thought about it before, then, well, now you've thought about it. It's what this missing 4% was, that it wasn't just 5% of 500, $25, 6 times. It was also an extra little bit, an extra 4%, because the payments kept going up. So that's the pattern that we sort of have now hidden in this formula. You can't see the 25 and 26 and so on anymore, but they're in there. So the English word compound means 2 different things. It could be an item made up of multiple and different parts, like a medicine that's a compound of ingredients. And it can also be an item that's made greater by a certain kind of thing, like strong winds compounding the difficulty of putting out a forest fire. So compound interest uses both. There were lots of little parts, and the interest for each step got bigger as time went on. Note that compound interest is not a math decision. It's not like we have to, as mathematicians, say, is this loan simple interest or compound interest? Right? That's a real life decision where the bank says, this is compound interest in your savings account, or the credit card says, this is compound interest for your credit card payments. So we don't get to pick when things are simple or compound. That's just somebody decided what loan to make. Whenever the payments stay the same, that's called simple interest. When the interest also earns interest, that's compound interest. So we had the picture above where the simple interest payments were the same year after year. For compound interest, the picture looks complicated. The first year we have a certain percent, like 5%. The second year, we also have another 5%. That's the 25 bucks. But we have a tiny bit more. It's now 26.15. So there's an extra $1.15. In the third year, we still have that 25 bucks, and we still have a little bit more from interest on the 25, but this purple interest will also earn interest, and so on. So if you are to draw what this looks like in a graph, then it goes up and up, steeper and steeper. Okay, so compound interest gets bigger and bigger. Let me try and make that nicer. So this is what people refer to as exponential growth. It just gets bigger and bigger and runs out of control. You know, you have to pay off your credit cards as fast as you can. You could make tables like we did, but tables are annoying. It was nice that we had a formula, because formulas are much nicer than tables. So now you can be happy that you did all of that work with formulas and tables and patterns at the beginning of class. So let's write it nice. We've done a lot of work. We deserve to write it nice. All it is this. We're just putting the words to it nicely in the formula. But if you're ever confused about it, just look back at this slide where you understand what's happening with the rent. So it says that the final amount, oops, actually, let me make it in one line. So shrink it. No, that's too small. Okay, it's just not turning into one line. That's annoying. Okay, well, then it's 2 lines. So the final amount is principal times the 1 plus trick, where we add 1 to the interest rate, and the exponent is the number of payouts. So we took our principal, we used the 1 plus trick, that's where we got the 1.05s. And how many times do we do it? As many rows are in the table. Now, our example problem had years, but in real life, most compound interest happens monthly. Is that too big? Can I shrink that some? Is that all readable? Holler if I made it too small. Okay. So as before, whenever we do a formula, we want to keep ourselves organized. So in this case, final amount is one thing. The principal, the rate, and this is a rate per payout, and the number of payouts. So if I keep myself organized off on the side, then once I plug things in, life will be smooth and happy. Anything tricky is going to happen over here. So the final amount is what we're solving for. And the good news about compound interest is you're always going to solve for the final amount. The complicated thing we did much earlier, we can't do that with compound interest. You don't have the tools in Math 25 to solve for something in the middle with an exponent. So because the formula is just a little bit more complicated and has an exponent, I'm not allowed to ask you to solve for any of those things. So you're always going to solve for the final amount, and that's nice. Okay, the principal, it's a $100 loan. That one's easy. The rate per payout. So the rate is 3% per year. So that's going to be 0.03 per year. Now, not only do we not get to pick that it's compound interest, we also don't get to pick that it's monthly. So we just have to deal with the fact that it's monthly. That means that every month we have to pay a little interest. Fortunately, we don't have to pay the 0.03 each year. That would be horrendous with a credit card with a 22% interest rate if you had to pay 22% of your debt each month. So we split it up. We share the 3% among the 12 months. And we get 0.0025. That's hard to read. I'm just going to have to move my number of payouts down. Okay. Okay, how many months happened? 18 months. And I want to double check that this is months and this is months because everything is monthly. Both of these have to be in months. That's all the hard part. Now it's just easy. So the final amount is 100 times. Now we have a 1 in the formula. So there's my 1. And 18 as an exponent. And my calculator does this just fine. 100 times 1.0025 exponent 18. And we get $104.60. Everyone get the same? Check right now that your calculator does this. Otherwise, when you try and do your homework, it's going to be problematic. Say something or give me a Zoom thumbs up if your calculator gets that in.
Couple more minutes. I need another minute.
Okay.
Do you see my thumbs up?
I see your thumbs up. Thank you.
Okay.
Too many people are quiet, but that's okay. Their problem if their calculator is secretly confusing.
So David, I don't think I'm putting it in right.
Okay, I'm
I
gonna
think
stop.
it's so,
Let me stop sharing and stop recording, and you just hold your. Okay, so on her calculator, what she needs to do is 100 times 1.0025. Her exponent key looks like a caret symbol, a mountain. 18 equals. If your calculator has a button that instead looks like y to the x, you will still notice that on the display, it shows you the caret. So the caret is the official symbol for exponent happens. Okay, I see a fist pump. She is happy. Okay, good, good. If you're doing a spreadsheet, the caret is also what you do. So, okay, this is kind of weird. Let's talk about it more now that people have said their calculators work. There's parentheses on this formula. Why don't we need the parentheses?
because we're using an exponent button.
Yeah, the order of operations will always make exponents happen first anyway. The parentheses were putting the 1 and the decimal together, and we did that. We just put a 1 in front of the 0.0025 with the 1 plus trick. So we don't need to write the parentheses. You could, I mean, there's absolutely nothing wrong with putting a parentheses here. It's just kind of silly. That's just one number now, because we put the 1 on with the decimal. So this formula looks pretty hard when you look at it as words. But when you're actually plugging things in, it's just 3 things. The other thing I want to point out is the simple interest formula spits out the interest only. If it asked us how much does this person pay back, we would have to add the loan and the interest together to get the new total. The compound interest formula, because of how it works, gives us that total. If somebody said, what is the interest? It would only be $4.60 because the 100 was around 4 as the loan. So the question could still ask you, what was the interest? And then you have to subtract away the principal. But in this case, it asked for the total loan, so we were good. Let's keep going. So that's what this is pointing out. If it asked just for the interest, we'd have to subtract away the 100. Oops, go back now. Okay, here's a more exciting thing. Rather than just $100 for only a short amount of time, a little more than a year, let's have a longer time frame. So now we're doing 30 years. And a slightly higher interest rate. Now this one is strange. It didn't say compounded monthly. So by default, if it doesn't tell you, then it's always annually, once a year. 。 . 。  . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . just like simple interest is defined per year. If they don't tell you when it's compounding, then it's annually. So that means that both these numbers need to be in years on this problem. So this will be nice. This is going to be the equivalent of the easy simple interest problem, where we just find things, plug them in, and bam, we're done. Okay, so we'll still get organized, because if anything did happen, it would be over here. Oh, actually, I am making a mistake. This is a simple interest problem, so let me get the right one. I'm jumping ahead. This one says compounded monthly, so that's the one I'm trying to do. I'm sorry, I should have noticed. Okay. So it is indeed true that if it didn't say how much you are compounding it, it would be annually, but this one it does say monthly. Okay, so where were we? Monthly. So again, the 9% is for a whole year. Each month I need to divide by 12. .0075. The number of payouts, we have 30 years. So how many months will that be? What do I need to do?
Divide that by
Not divide.
times.
Times. Each year has 12 months. I have 12 and 12 and 12 and 12 and 12 and 12, 30 times. So that's going to be 360 months. So that's good. We have months. Whoops. And all of our things are in months. That's what we want. Did I leave that green? I did. Okay. So everything matches. My setup is done. Plug things in. I have that yellow 1+ trick happening, same as before. So what is that? 2,000 times 1.0075 exponent key 360, 29,000 $461 and 15 cents. Okay, questions on that problem? I do want to do the easy one that I thought I was doing before, so let me get one of those. Are we sure we can leave this slide? Everyone's okay. Do we have... No, okay, well, let's go to homework then. No, that's not going to happen. Is there a turn-in one? That's just a plain easy one for you. We can start this one, sure. So this turn-in problem, I should get the ducks too. Has the same setup, but for one of them, it is weekly, for one of them it is monthly, and for one of them it is annually. So you're doing the same problem 3 different ways. So let's do the annually one. I want you to see the simple case before we're done today.
Thank you.
For homework, you'll have to do the other two. The monthly will look just like this with a divided by 12 and a times 12. For the weekly, it would be 52 because there's 52 weeks in a year. So you'll divide by 52 and multiply by 52. So this 0.09 is per year, and the 13 is 13 years. So everything matches because this is the annually duck. We don't have to fidget with them because it's already matching the per year. If it was weekly, we would fidget times 12 divided by 12. If it was monthly, monthly we fidget with the divide by 12 and times 12. If it was weekly, we'd fidget with the divided by 52 and times 52. But for this one, we don't need to. So it's nice, we just plug it in. Oops, I need my principal first. So whatever that is, 5,000 times 1.09 exponent 13. So $15,329.02. Everyone get the same on their calculator?
Yeah.
Okay, good kindergarten present. There we go. Whoops, that's not what I want. Okay, so the point of this slide is there's two different kinds of applications in real life for compound interest. If all I'm trying to do is budget saving for retirement, which we'll talk about a lot in the next few classes, then we don't have to worry about monthly or weekly or things like that. We can just say, let's make it compounded annually. The per year is nice. The formula is simple. And we can sort of say, if I save this much, how much will I have later? On the other hand, if you're into the nitty gritty, if you have credit cards or things, and it's actual monthly, then you have to do your divide by 12 and times 12. Although hopefully you're not leaving your credit card unpaid for 30 years. That would be terrible. Okay, some people don't like all this fidgets. So if you don't like the fidgets, then just memorize different formulas. Have the annual compounding formula without any fidgets. Have the monthly one with the times 12 and divided by 12. Quarterly means each quarter of a year. Some stock dividends are quarterly, times 4 and divided by 4. Or weekly, times 52 and divided by 52. Since everything you do is open notes, if you want 4 formulas, you can. But they're really all the same formula. So whatever makes you happy. And there's some videos if you want someone else explaining what we just did. And that's a good place to stop. Let's do another example from the homework.
Let's do one with the double and up stuff.
One with the double what?
Does doubling the monthly or doubling the length, halving those?
I want to do this one first. That's a good one to start next class with.
Okay.
But this is the kind of one that's going to sort of transition to where you're going. Okay, what happens here is that somebody moves money between accounts. So there's 12 years with a 3% annual interest compounded semi-annually. Semi-annually means twice per year. And at the start of the next year, he moves it to a different account with a different interest rate and a different type of compounding. Now it's weekly. So there's two parts, a part A and a part B. And this will be something that'll take us about all 6 minutes, and then we can be done. So part A is going to be our first 12 years. So we have Final amount. Principal. Rate per payout. Number of payouts. So this starts out with 3% annual interest and semi-annually, which means twice per year. So I have to divide it by 2. So 0.015. Rain is not sludge, even though I feel like it. Okay. And 12 years. Move away, moving. There we go. And then we have to multiply by 2. Okay, everyone okay with my setup? Except that maybe you've never heard of semi-annually before, but all it means is twice a year. So now I'm going to plug it in. So we get 8,000. That doesn't seem right. 3,000 times 1.015 x. Oh, I guess it is. Okay, so far so good.
Yeah, 4288.
Yep. Okay, now we need part 2. Isn't it erasing it? So we have 35 more years. Make that look more like a 5. So 12 years at one set of stuff, 35 more years at another. So this time it's compounded weekly. and has a 4% interest rate. So same setup. And it is 11:30. If you need to go, you can always see the end. I understand. That's number of, not number. Oh, okay. Now, how much are we starting with? It's not 3,000.
Is it the 42?
It's the 4288.51, right? Whatever he had before keeps going. Okay, rate per payout, 4%. Don't want to write all of this, you don't have to. You could just jump right to 0.04. What are we dividing by this time?
Weekly
Yeah, what was the number for weekly?
52.
So something tiny, 0.04 divided by 52 is going to give me 0.007693. Don't round in the middle. And then the number of payouts, we have 35 years. Times 52. $1,820. Everyone happy with my setup? Okay, 4288.51 times 1.0007693 exponent 1820. I'm getting $17,000. $381, 30, not 38. So that's the most annoying I can possibly make these, where somebody switches game plans in the middle of the story to make it two parts, to make the principal something that's tricky. And let's use weeks, because 52s are just big numbers. And let's use semi-annually, which you've never heard of before, and back and forth, right? So if you can follow this example, you're good. There's nothing that can be worse than this. Okay, we're done for now. So maybe see you later at the study session. Have a good lunch, or maybe see you in a couple days.
Thank you, David.